Hi, my name is Christian Hernandez, and I'm a Senior Principal Technical Marketing Manager at the Cloud Platforms Business Unit over at Red Hat. Today, I'm going to be talking about GitOps and the 3 foundational tips to better secure your practice. Some of the things I'll be going over is what is GitOps? So GitOps has become a sort of buzzword as of late. So I'm going to be going ahead and distilling down what GitOps means and also trying to go a little bit beyond the buzzword. Next, I'm going to show you how GitOps automation gives you more control of your environment. And lastly, I'm going to be talking about GitOps as a path to your DevSecOps journey. So first, let's talk a little bit about what is GitOps. So you can't talk about GitOps without talking about DevOps. You know, the business landscape is constantly changing, and with these changes, it also changes how we approach software delivery, including an increasing demand to deliver for rapidly, also to try to stay ahead of the competition and adopt new business models and move into new markets. To meet these demands, organizations are increasingly adopting DevOps principles, where you're taking your development and your operation folks and making them work together to deliver your application. CICD is a prominent practice in the DevOps movement and focuses on frequently delivering application to customers by introducing automation into the stages of app deployment. The main concepts attributed to CICD are continuous integration, continuous delivery, and continuous deployment. Specifically, CICD introduces an ongoing automation and continuous monitoring through the lifecycle of the application, from integration and testing phases to delivery and deployment. Taken together, these connected practices are often referred to as CICD pipeline. And they are supported by development and operations team working together in an agile way with either a DevOps or an SRE, what we call site reliability engineering approach. Continuous integration is an automation process for developers. Successful CI means new code changes to an application are regularly built, tested, and merged to a shared repository. In a solution to the problem of having too many branches of an app in a development at once that might conflict with each other. Continuous delivery refers to an automated releasing changes to stage and pre-production environments, which can then, with approval of operations team, be released into production. It's an answer to the problem of poor visibility and communication between dev and business teams and automating all the manual steps that is needed to deploy an application. Continuous deployment is another possible CD, which is similar to continuous delivery. However, changes are deployed into production automatically. This is without any manual intervention. So that brings us over to GitOps. So GitOps is a developer-centric approach to continuous delivery and infrastructure operation. It is basically the idea of taking the workflow of the developers and also doing it for your operations. So this has certain pillars to it. First is Git is a single source of truth, where you treat everything as code and all your operations are done through Git workflows. So I'm not talking about just application delivery, but also operation and system admins also use Git as well. So everything is as code. The entire state of the infrastructure, applications, configuration is defined declaratively as code. This includes how the infrastructure looks like, how the application behaves, and how the application should be deployed and configured across environments. Even the CI/CD infrastructure needs to be treated as code and follow the same principle. Git is the source of truth. So the state of the infrastructure and applications are stored and versioned in Git, where the name GitOps comes from. Git is a version control system, and you take advantage of the traceability and visibility of that what Git provides for the entire state of the infrastructure and the application. Any change that is available somewhere in the infrastructure and applications must be first represented in the Git repository. Your workflows are going to be operations through Git workflows. So provisioning and deployment performed through familiar Git pull requests workflows. The pull request or merge request workflow is similar practice for application deployment and developers. The idea of GitOps is to apply the same workflow to any change that goes into the infrastructure and its applications. Changes are proposed through insinuating a pull request to the respective Git repository. And after reviewers and approval process goes in place, it gets merged to the repository and then applied to the target infrastructure. The complete history of changes, review process, and deployment is visible through Git history on the Git repository. So taking this approach, we can see what the application delivery model would look like on Openshift. Everything from the CI process to the CD process now takes place inside of Openshift. Openshift, which is based on Kubernetes, is the first time we actually get declarative infrastructure and fits in perfectly with the GitOps model. So now every part of this gives you a Kubernetes native way of delivering your CI/CD workflows. You can build an application natively with Shipwright using OpenShift builds, integrate new code continuously with OpenShift pipelines, which is based on Tekton, and you can deliver your application and infrastructure automatically using OpenShift GitOps, which is based on Argo CD. So now you have a cloud-native way of doing your GitOps and CI/CD workflows. So before we saw the application delivery model on OpenShift, let's take a look at the operating model on OpenShift as well. So here, in general, GitOps operation model looks like this, where the application developer can push a change and open a PR either way into the application repo. This will trigger a OpenShift pipelines, a CI/CD pipeline, which will build the application, and it may or may not push a new container image into the registry. The pipeline updates the image manifest inside of the environment repo. At the same time, the infrastructure admin can make a change, requesting a change to the infrastructure if it's needed. And OpenShift GitOps, again powered by Argo CD, continuously monitors the desired state and then the current running state and reconciles that, applying any new updates if it's needed. So let's talk a little bit about GitOps at Red Hat. So GitOps isn't a tool. You can't just go and buy GitOps off the shelf. You can't say, give me one GitOps, please. It's not a tool, but a practice. What you use will vary depending on your workflows. While many tools that you can use for GitOps, Red Hat Ansible automation platform stands out as the ideal solution because it can extend your workflows beyond Kubernetes to all existing infrastructure. So very rarely do you have just a Kubernetes platform that you take care of. You may have some ancillary applications or some ancillary systems that you may need to connect to and automate. Ansible is perfect for that. OpenShift now, as I stated before, now delivers a cloud-native GitOps workflows with using Tekton and Argo CD. So application developers and operation teams can now keep the OpenShift cluster continuously in sync with the desired state. And then using Red Hat Advanced Cluster Manager for Kubernetes, now you can take that same approach and deliver it to multiple clusters across different regions. So now that you've automated your OpenShift cluster, now you can have a declarative cluster lifecycle management, have compliance, do policies among many OpenShift clusters across many geographical dispersed regions. And this is possible through Red Hat ACM. So what you use and the combination of tools that you use is going to differ depending on your workflow. And Red Hat has a solution for each one of those situations. Now let's talk a little bit about automation. Automation does not have to be scary. When you talk about automation, a lot of the times, a lot of red flags go off, but it doesn't have to be that way. So your day-to-day in GitOps will look something like this. Your interaction with your environment will be done via Git with a series of PRs and merges. This is the same experience as your dev team has, but now it's taken to a whole new level. This has many advantages, which I'll go over in a bit. But just to kind of go over in a high level is that your day two operations and how you interact with your cluster is going to be with a series of Git PRs and merges, which then will trigger some sort of automation. So one of the advantages of this automated approach is in Git is that you now have a built-in audit trail. So your environment now has a convenient log of all the changes that have been applied. So since you're using Git, all your changes in your environment now can be auditable. So the state of the cluster at any given moment can be pulled from the logs. So the who, what, when, where, why of every change in your environment now has a history, can be tracked, can be pointed to. And this actually makes a lot of things easier, right? Especially when you're auditing your system. One of the things that makes it easier is makes your root cause analysis a lot easier. So when an issue does arise, one, you can quickly revert back to a known good state, and two, you can see what the central cause of that issue was and when it was made, and then you can make decisions on whether or not you can rectify that change in the future. Another advantage is that this gives you the ability to have code review for your infrastructure. So the process of code review verifies what changes will be applied. So everyone can take a part of the review process, from operations to development, and even the line of business can take a look. The process can be even viewed as sort of change control as code. Breaking changes can be seen way before they are applied. So the more eyes you have on a change, the better it is for your environment. Issues can be called out almost immediately. Another advantage of using this sort of automated workflow is you can actually gate those changes. So the process of PR requests and merging, all of that can be gated. Although you can have changes fully automated, it doesn't have to be that way. Each step of the process can be gated and put through an approval process. GitOps is about keeping your desired state synchronized with the current state. It doesn't necessarily mean all changes go through or all desired changes can go through. It just means that when the changes are approved, the application of those changes is automated. So this is kind of one of the misnomers of automation, is that everything gets put in through automatically. That's not the case. Another advantage of GitOps in general is the automatic reconciliation. So GitOps is a declarative environment delivery model. So changes made directly to the environment are flagged. They are either flagged as out of sync, or they're automatically reconciled. You can have both, one or the other. This kind of gives you a hands-off approach to rectifying drift, right? When there's a drift in your environment, then you'll be able to automatically reconcile that so that your environment stays in the desired state. Next, we talk about protected branches. So protected branches in a GitOps environment, it just prevents changes to a particular environment or deleting of a particular environment. This means that no one can do like a force push to the branch. It has to go through an approval process. And also it prevents anyone from deleting a branch, either maliciously or accidentally. It prevents pushes from everyone except users with allowed permission. So you can still have, this goes back to the gating conversation, is that you can still have certain people be like your delivery team. And, once all of that's approved, even when it's all approved, still only one person can then merge that change into the branches. So that's the idea behind protected branches. So as you can see, automation doesn't have to be scary. There are things built into Git workflows. that help alleviate some of the worries people may have in terms of automation. Some of these gating features and things that are put into place were put into place way before, with developers also experiencing this workflow. Now we're just doing this in operations, and you can leverage the same gating and feature set. So let's talk about the path to DevSecOps. So GitOps is the foundation of many DevOps delivery models. So GitOps, in practice, is the core of a lot of DevOps models, as it were. So many people say that that GitOps is what DevOps looks like in practice. So the core functionality of DevOps is actually GitOps. So and it's then used as a foundation for a lot of things. So things like AI ops and AI ML ops uses GitOps as a foundation. No ops as well, and of course DevSecOps. GitOps sets the groundwork for many of these operating models. So let's take a slight step back here, and just kind of as a reminder that DevOps is a cultural shift. DevOps isn't like a department inside of your organization. It isn't like a single person or a single group. It's an actual DevOps is a cultural shift. DevOps is everyone. The cultural shift is acknowledging that everyone has valuable input and ideas. Not only does everyone have input, but is also involved in the entire process. So things like you no longer have silos from the developer aspect and the operations aspect, or the sysadmin from the line of business, or from the network admin to the cloud admin. They're all working together in constant communication. So this is a cultural shift more than anything. And what I mean by when I say everyone, this also includes the security team. So let's talk about how things used to be like. So traditionally, security always came at the end of the process. So in your application delivery process, application delivery model, for whatever reason, security always came at the end of the process. And this is especially true when you're doing something like waterfall. It usually causes delays, is what it is. It causes unnecessarily delays. So security is an important subject for every department. So everyone's security conscious. Everyone thinks security is important. So then why is it only brought in at the end of the cycle? Really, security needs to be moved from a downstream task to an upstream task. And actually, more specifically, your security goes from being the last part of it to actually being a part of the whole process. So DevSecOps is simply security as part of the whole process. So bringing in security sooner to identify any possible issues. DevSecOps means thinking about your application and infrastructure security from the start, from the ground up. It means, taking some of those automation pieces that we talked about earlier and baking in security along with them. DevSecOps is about built-in security, not a security that functions a perimeter around your applications or data or your environment, right? It's not like a fence you put around something. It's built in. It's part of the core of what you're delivering. So if security remains at the end of the development pipeline, organizations adopting DevOps can find themselves back just in a long development cycles, right? So you're just moving the issue downstream a little bit. Keeping security and your security teams in the process, in the loop, when building your DevOps workflow is paramount. So DevSecOps is essentially just adding another chain to that whole loop. Is DevSecOps is security in your DevOps model. Speaking of DevOps model looks something like this, right? So you want to be able to design, build, package, deploy, run, manage, adapt, and then design, and then you keep this whole loop of the continuously delivering your application. This is a visual cycle, right? It's all about shipping, feedback, communication, trust, all that stuff. Now you want to plug in security to that, right? And the DevSecOps model is, we talk about continuous integration and continuous delivery deployment. You can add another C acronym to that, right? Instead of CICD, it could be CICD CS, right? Continuous security. So, it becomes part of your whole process of your CI/CD process there. So first, you want to do something like you want to, part of the delivery is having the security aspect of it, like identifying, right? You develop our organizational understanding to manage cybersecurity risk into systems, people, assets, data. So you want to be able to identify issues that may come up. You want to be able to have a process to be able to identify, potential threats and current threats. Next, you want to be able to protect, right? So protect, you want to develop and implement appropriate safeguards to protect your environment and your in critical services as well. Once going further down that loop, you want to be able to detect it, right? So it's one thing to identify and one thing to try to protect against those. You want to be able to detect when they're actually happening, right? So you want to be able to automate systems for security and compliance. You want to be able to quickly respond to those, right? Develop and implement appropriate activities to take action regarding and detected cybersecurity incidents, right? So you want to be able to respond to that automatically. And also, you want to be able to recover from that. So you want to be able to recover from any potential threats or any current threats and put that as part of the automation. So then now you can see that the whole security process now is part of that same loop, right? So you're just plugging in security as part of this whole DevOps loop. So thank you very much for attending. I hope that you're able to see how GitOps is a foundation tool for your DevOps practices, and also how it can be your foundation tool to extend those DevOps practices to your security teams and in your environment. Thank you. Thank you, everyone, for attending the webinar. I'm going to jump in right now to answer some Q&A. So the questions are coming in. There's a lot of questions, a lot of good questions here. So first comes, how does GitOps differ from infrastructure as code? And this is a great question. This is a question I actually get a lot, the differentiating between GitOps and infrastructure as code. So GitOps does look like infrastructure as code. So I don't blame people for kind of conflating the two, but it's not necessarily that they're being conflated, but it's because GitOps actually uses infrastructure as code. So part of the GitOps process, part of the GitOps practice is to actually use infrastructure as code. So as part of implementing GitOps, you're just going to naturally use infrastructure as code. So kind of like the idea of a truck is a vehicle, but not all vehicles are trucks, right? So just infrastructure as code by itself isn't GitOps, right? It's a part of a bigger picture, and it's more than just syncing YAML and making sure your infrastructure is always in sync. So that's only just one part of the bigger picture. It's not necessarily that it differs, but GitOps actually uses infrastructure as code, right? It's a natural progression of using GitOps. You're just going to naturally use infrastructure as code. So next question here is, can you shed some more light into how the PR is created to change the manifest in a GitOps workflow? Great question. This is a question that I get a lot. This is actually something I went through with a customer of mine. So your CI process will have like a step or a task, right? I'm using Tecton terminology here, but it's the same if you're using Jenkins or Cloudbees. Is that part of that CI process will make a PR into the repo. So it could be, one of the last steps is, after you build your code, after you build your image, it'll make a PR into your repo. And, as part of that process, and, can send an alert for someone to take a look at it. A human, right, also can do that PR as well. It doesn't have to be machine or process driven. It can be a human like me. Like I can actually go and request a change. Like as a developer, right? Maybe I need something. I will actually submit that PR. But everything is done through normal Git workflows, and so which is that Git part in GitOps is that it's not just that you're syncing you're using it as infrastructure as code. It's not just that you're syncing the configuration to your running cluster. It's not just that part of Git. It's also the part of Git of your Git workflows. It's code review. It's protected branches. It's the ability to roll forward, roll back. Right. It's the whole Git workflow part of it. Right. So whether the CI process makes the change, right, is part of one of the steps, or a human does it, it's going through that same Git workflow. And Argo CD, right, is just acting on it, right? The agent is using, it's just acting on the Git workflow. So next question here. This is a great question. So can I use a CI server to orchestrate the convergence in a cluster? So this is a great question. So short answer is yes, you can. Long answer is yes, you can, but it's not GitOps, right? So you can use it, and there's nothing wrong with doing it that way. It's actually a perfectly valid way. But the difference between GitOps and using, like a CI/CD process like Jenkins, right, or even Tecton, Tecton can do the CD process as well, is that you're doing an event-driven versus a reconciliation loop, right? So the event-driven is, you have to do something to trigger it, right? You have to you trigger the pipeline either with a like a Git push or like a webhook or something. Something has to trigger that, and in order to see the change, an event needs to be triggered. So whereas in a reconciliation, in a GitOps, using GitOps and that reconciliation loop, is that there is an agent constantly there monitoring your cluster and using the input from Git, right? Where it's like, okay, I'm always going to make sure your cluster is synced with this particular branch, right? Like main, let's just take for example. So anytime there's a commit to main, it'll see that difference and it'll reconcile it, right? So that's the idea. It is a nuanced difference, right? It's a little difference, but that's the difference between GitOps versus event-driven architecture, right? So in what you gain with GitOps is that auto healing and that making sure the cluster is always constantly in sync. Next question here is, how do you lock down the Openshift infrastructure so that no one else has access to make changes? Great question. So again, I mentioned the idea of software agents. So software agents like Argo CD, right? Openshift GitOps is based on Argo CD. Is the agent has total control of the cluster, meaning that if someone makes a change and auto sync is turned on for Argo CD can detect that drift and then reconcile it, meaning that it'll just switch it back to what you declared, right? Your declared state or your desired state that's in Git. It'll reconcile it back to that state. And so that's part of Argo CD. That's Argo CD's strength, right? And that's part of that CI/CD process, where that CD process it's not just delivering, but it's also reconciling, monitoring, and then doing that whole reconciliation loop. And if you're using something like Argo CD for your for your CI/CD, developer-driven GitOps architecture, you'd use Argo CD with you can do that to a fleet of clusters, right? So now we're stepping back and looking at things from the operations aspect, from the security aspect, you can use something like the Red Hat's Advanced Cluster Manager to then do the same thing that you're doing with Argo, but to a fleet of clusters, right? So you're doing it, thousands of clusters, right, spread across geographical regions. You can use ACM to do that same sort of reconciliation, right? That lockdown of the cluster. So that may, you can ensure that your entire fleet is always in sync. All right. Next question here. How do OpenShift GitOps and the built-in ACM application capability compare? Okay, so this is I guess related to the previous question, right? So that I'm talking about ACM and how it handles a fleet of clusters. And then you hear me talk about Argo CD and CI/CD, and you will hear that there's a little bit of overlap, and it's actually not using one over the other. You'll actually use both in tandem. So it's not an or, it's a yes and sort of answer. So you'll use Argo CD and you would use ACM, right? So Argo CD is essentially for your CI/CD process for delivering that last mile, that last you have this whole process of your CI process, and then delivering that application at the end for your CD process. So now doing that in mass, right? You're going to use something like ACM, because the ACM will handle a fleet of Argo CD instances for you, right? And ACM also goes above just keeping your clusters in sync, but actually managing the life cycle of your cluster. So with ACM, you can spin up and tear down clusters as part of your process as well. So it's just ACM not only will build the cluster, will then deploy Argo and then sync the application that you want onto that cluster, and now you have a fleet of Argo CD instances. So yes, you actually use both of them in tandem. A lot of our customers do use both of them in tandem, and that's one of the ways that you can get Argo CD like in mass, right, in over many clusters. All right, next question here is, how do you manage secrets? Love this question. This question is always comes up, and this question is really hotly debated. I think it's still hotly debated. I don't think there's a general answer just yet, right? There's two schools of thought. There's one that you use something like sealed secrets. So sealed secrets is actually something that came up from Bitnami, right? Bitnami Labs. And essentially is that you encrypt your secret and you would store the encrypted version in Git. And so in Git, you'll actually store, you start talking about GitOps and you start talking about people, oh, hey, I'm going to store everything in Git, including my secrets, username and passwords. What, like, the first answer is like, it sets up red flags, which it should set up red flags. Well, Seal Secret aim to solve that problem by encrypting the secret first and then putting up in Git. And so, and then when that secret is then decrypt on runtime on the actual cluster. So that's one way of solving that problem. Another way is using Vault, right? HashiCorp. So you can use Vault Vault is more than just it goes above and beyond just like handling secrets. It actually is a secret management system, right? So it's like actually an actual platform that manages your secret, the lifecycle, rotation, all that good stuff. And then there's other things. There's other projects coming up like external secrets, and there's one by Mozilla. I forget the name out of the top of my head, but there's other ways of managing the secret. So there is. It looks like everyone's either falling on either on the sealed secrets camp or the vault. I think the jury's still out on what like the actual best practice is. I think the best practice is don't store the secret in clear text in Git. And I think no matter how, however you solve that problem, I think it's fine. Right now, I think like sealed secrets and vault, I think are the top two of what I've been seeing out there that our customers are using. So I mentioned, so it says you mentioned keeping application code separate from your infrastructure configs. Can you elaborate on that? Yeah. So in the presentation, as you saw, that part of it is that I talk about keeping infrastructure configurations separate from your application code. And really, the reason I do that, I first used to have it like all in one code and code base, right? All in one repo. But then I split it out in two repos after been working, with GitOps for a while. And that's because they just have different life cycles, right? Your infrastructure has a different life cycle than your application life cycle. So like an infrastructure change shouldn't, you shouldn't have to rebuild your application image if there's been no change, right? So you just basically build, do your infrastructure change and just reuse the same image that's already starting your repository. And the way I do that, right, and kind of I'm just gonna expand on that a little bit, is that I actually use Kustomize, right? So it's a templating agent. When you're storing everything in Git, there's a tendency to duplicate a lot of YAML. And in order to avoid that, I use Kustomize. And with Kustomize, has the idea of like your base configuration and then overlays, right? Things that you overlay on top of your configurations, right? And so part of my CI process is that I take Kustomize and I update the environments based, update like the image. For example, I update the image tag based on either environment, right, like dev, production, or like the cluster I'm on, cluster 1, cluster 2, cluster 3, depending, right, what kind of workflow you're doing. So I'm not a big fan of using floating tags. I actually use like either a descriptive tag or something like a hash of the Git commit that I've used. I do, I chop off a part of the hash and use that as a tag. I'm not a big fan of floating tags. Because I like to see, to know what commit corresponds to what image that's running in the cluster. So as part of my CI process, I use Kustomize to update the image tag essentially after my build is done. All right, next question. Can you bypass the CD process in case of emergency? So yes. So I absolutely love this question. Yes. So a lot of times you hear me talk about GitOps, how everything's reflected in Git. You don't touch the cluster, you do everything through Git. But there is the idea of what I like to call breaking glass, right? Like there's like an emergency, we have to do something, we need to fix it now. That's definitely possible. That's definitely within the realm of GitOps. Also, tools like Argo CD and ACM, they have a way to pause the reconciliation, right? So you can like turn off autosync. You can pause autosync in Argo CD, for example, and do whatever maintenance you need to do or whatever emergency situation you need to do. Argo also can be used in an event-driven. So remember when I was talking about the difference between event-driven and GitOps, reconciliation. So you can use Argo CD for either a GitOps tool or just for a simple event-driven and just have autosync turned off. That's completely fine if you want to use Argo CD that way. Also remember, you can do rollbacks and roll forwards because it's all based on your Git workflow, right? Argo CD, excuse me, your Git workflows, right, is going to be reflected on the cluster. Whether you're using Argo CD, whether you're using ACM, or whether you're using both in tandem, what really matters is the Git workflows, your process that you built around Git, and just the tools are just going to be in the reflection of that. And so, yeah, so that's kind of a long-winded way of saying yes, break glass is definitely fine. Is definitely possible also with Argo CD or ACM when you're doing that here. So next question here is, can you dive a little deeper on the relationship between GitOps and DevSecOps? Yeah, so good question. So kind of like I mentioned before, GitOps is a practice. DevSecOps is the same thing, right? It's not necessarily a thing. It's an actual practice, and they're more like practices than anything else. And it's just now the technology is catching up with the practices. But you can think of GitOps as a core to DevSecOps, and DevSecOps or merely means that security is involved along with Dev and Ops, right? So that's a kind of, you have DevOps, and many of the times, like I said in the presentation, security is kind of at the tail end of that. DevSecOps is, let's bring them in, and have them, whatever's important to them come up, like image scanning, reporting, tools for response, for example. So GitOps, the relation between GitOps and DevSecOps is essentially GitOps is a foundation on how to enable DevSecOps in today's world. So and then actually the next question is actually pretty related. It's a good question. So can you give us some use cases on how you can get security into the process? Yeah. So yeah, some places, right? Some customers that I work with, that like security actually doesn't want to be that involved, and not in a bad way, right? Like they don't necessarily want to be the ones to do the coding. They don't necessarily want to be the ones that they don't want to be part of the developer process, right? There's a lot of security teams that do that, but DevSecOps really, it doesn't have to mean that their hands are on keyboard, right? It means finding out what's important to them, right? So every vertical, right, every member of each team is going to have something that's important to them, right? The infrastructure guys are going to have things that are important to them that are different than the developers, and same, the security guys are going to have something to them that's important to them is going to be different than the operations folks. And it's just finding out, right? DevSecOps is literally just bringing security in early in the process, so you know what's important to them. So then you can do things like, okay, well, we're going to put in image scanning. What kind of vulnerabilities do you want us to look for? What kind of things should we look out for, right? What will make us pass the security check? Bringing those in early and often, having those communications. What sort of things you can do during the process to expedite those security checks. And it's just like anything else, DevSecOps is a practice, and it's all about, just like DevOps, communication, right? And so it's the idea of bringing security may be foreign to a lot of organization, but it's merely more about taking those security practices and taking those things that are important to the security team and building those in your GitOps practices. So let me take a look to see if there's any more questions. I believe that's it. Yep. All right, no more questions, it looks like. So I want to thank you all for attending this webinar. It was some great questions that are coming down, and I invite you to try out Openshift and Argo CD, ACM to see how it can help in your GitOps practices. Thank you.